right here. Yeah. So when you're talking about inverse functions, basically the idea is you should have one-to-one functions before you can even find the inverse. And one of the tests that we were doing for one-to-one functions was, using that horizontal line test. So the idea was if you draw a horizontal line through your graph, what should happen? Right, exactly, which means that you should be crossing that horizontal line only at one point on your axis, right? On your horizontal part of your graph. Okay, how do we get this guy out? There we go. So if you look at your sine, for that matter, cosine function, what happens if we were to draw a horizontal line through this graph? It would not pass, would it? Because obviously for the same y value, we would end up getting multiple x values because of the nature of what this function is. So that's kind of the interesting thing over here. So we actually have to restrict the domain of our sine function if we're actually going to be able to find an inverse function for this. So you will notice we're saying we are restricting the domain from negative pi halves to positive pi halves. So that's going to be this little darker shaded area right here. So if we're only looking at that little portion of the sine function, then of course it's going to pass the the horizontal line test, which means we can say that this graph is one-to-one. We can find its inverse. So on this interval specifically, you can see your sine function is increasing because you're going up, right? So your y values are increasing. They are saying this, on this interval, your sine function takes on its full range of values, which means that you are going from the bottommost value of the range to the topmost. Of course, you can see we're going from -1 to +1. And of course, we know it's going to pass the vertical, I keep saying vertical, the horizontal line test, which means your function is one-to-one. So that's something that, we had kind of looked at with a couple different examples in college algebra also. As long as you can restrict your domain, you can make your functions one-to-one. And so the inverse sine function, you can call it the arcsine function, or you can actually use that inverse notation, so sine inverse. So you will see both of those showing up interchangeably. So even if you see arcsine, arc cosine, same thing, we're talking about inverse functions. And then if you see the notation with the little inverse notation, kind of following our F inverse notation here, you just make it sine inverse of X. And then they're talking about just a little bit here in this paragraph here about how the notation of arcsine comes from that association of the central angle with the intercepted arc length. So if you picture a unit circle and think about, your central angle theta, in terms of that, if you are intercepting your arc length, which we had seen in, what was it, section 1.4, where we talked about arc length. Was it 1.3? Okay, I know it was in that first part that we talked about it. So anyway, when you're talking about arc sine of X, you're basically saying the angle whose sine is going to be X. So these calculations are actually pretty interesting when we try to work with these guys. So let's take a look at our example, and you can kind of read that paragraph a little bit more. But if you look at this image over here with arc sine of X, what are you noticing on this graph compared to that restricted domain that we have over here? So what did we say our restricted domain for the arcsine function was going to be? Between what values were we restricting our X? That was the y value.
Negative pi and negative pi halves and positive pi halves.
Yeah, exactly. And look at that. That has now become the range for your arcsine function, right? Because now your y values on the arcsine are going from negative pi halves to positive pi halves. And what are you noticing on the x-axis?
It's now to the positive pi half and the negative pi half.
For the y values, but what about the x?
It's -1 and positive.
Yeah, -1 and +1. So again, remember when we had talked about inverse functions, your x and y values interchange, right, from the original function to the inverse function. So in the original function, our x values were going from negative pi halves to positive pi halves, which will now become the range for your arcsine function. And then our y values were staying between -1 and +1 for the sine function. So those will now become -1 and +1 on your x-axis. So your x and y values are also going to interchange. So you should definitely make a note of that because that's something you're going to be seeing in all of these inverse functions. All right, so we are defining the inverse sine function or arcsine function as y equals arcsine of x if and only if you are actually taking sine of y equals x. So y equals arcsine of x if and only if sine of y equals x. So essentially, and there's a little bit of restriction that happens on this, but if you think about this guy here as your y equals arcsine, which is sine inverse of x, right? Now, if you actually take sine on both sides of this equation, that sine and arcsine will in a way cancel each other out, and you end up getting sine of y equals x. So that's kind of what that relationship is about. So if you kind of think about it in those terms, it might help you remember what that relationship between the arcsine and sine function is, okay? Like I said, there can be some restrictions on this part, but for general, if you think about it, then it will help you remember that relationship between the two functions. Okay, so keep in mind that for the arcsine function, your x values will be between -1 and +1, and your y values will be between negative pi halves and positive pi halves, just because we are restricting the original function, which means your arcsine is not going to be over the entire domain of your x value. So domain for arcsine is -1 to 1, range is negative pi halves to pi halves. All right, so let's take a look at this example here. They're asking us to evaluate the inverse sine function. They're giving us arcsine of -halves, sine inverse of square root of 3/2, and of course sine inverse of 2. So with this remark here, we're basically talking about with your trigonometric function, some work with the inverse trig functions can be done by exact calculations instead of doing approximation. So what they're basically saying here is, don't be dependent on your calculator, because if you're looking for exact answers, your calculators are more than likely to give you approximate answers, right? Because there'll be decimal approximation. So they're saying exact calculations help to increase your understanding of inverse functions by relating them to those right triangle definitions we had looked at in the first part of this chapter. All right, so let's see how we can go about finding the value of arcsine of -1/2. So we're actually, again, falling back on this idea of if sine of -pi/6 gives us -1/2, and as long as that -pi/6 is going to be within your range of the arcsine function, you are okay to use that value. So that's basically what they're basing this on. If the original sine function of -pi/6 is -1/2, then obviously using this relationship of sine of y equals x is the same as y of arcsine equals x, then your answer for arcsine of -1/2 is going to be -pi/6. And you will see we're kind of doing that same kind of reasoning here. So where is, or at what angle is sine going to be square root of 3/2? So again, you can use your 30, 60, 90 degree triangle if you want, and that's going to happen at pi/3. Now pi/3 is what degrees? 60 degrees, right? So yeah, that's what they are doing. So if at sine of 60 degrees or pi/3, you have square root of 3/2, which means the sine inverse function at square root of 3/2 is going to be pi/3. So basically just reversing what we had done with the right triangle trigonometry to help us come up with these values. Because, think about this. If you try to put this in your calculator, and you can try it, you're going to get a decimal answer, and they're looking for exact answers. Now, this last one here, sine of, sine inverse or arcsine of 2 is not working out. And what are they saying? Why is it not working out?
Because there's no angle, because it's outside of the unit circles.
Yeah, because the domain for an arcsine function only goes from -1 to +1, right? And if you're talking about finding sine inverse of 2, well, that x value cannot go outside of 1. So just because they're asking you to find sine inverse of 2 and that falls outside of the domain of the arcsine function, you don't have a solution. It's not possible us to find an answer to that. So again, that's something you have to think about when you're working through these sine inverse, cosine inverse functions, is what is the domain of these functions and are we staying within the domain? And that's kind of what we talked about in those first two examples. -pi/6 falls within the range, so we can use it. Pi/3 falls within this range, so we can use it. But x equals 2 is outside of the domain of our function, we cannot use it. Same thing would have happened with parts A and B. If the angle you came up with was outside that range of -pi/2 to +pi/2, you can't use that value. Then you would have to find something equivalent if there was one within the given domain, range, that you have. So using those same reasonings, what do you think happens with our example 1 over here with arcsine of 1? What value could we have?
Pi/2.
Okay, so let's do this here. This would be what, number 1. They're basically asking you what the value of sine inverse would be, right? Which equivalent would be at what value of y is sine going to be equal to 1? So think of all the possibilities we have for sine being equal to 1. So what numbers are we possibly coming up with? And again, you can use unit circle, you can use right triangle, trigonometry, because when you're talking about sine function, sine is going to be +1 at pi/2, right? Because at 3 pi/2, you're at -1, so that wouldn't count anyway. So really the only choice we have is pi/2, and this pi/2 within our range for the arcsine function. Yeah, because the range of the arcsine function goes from -pi/2 to +pi/2. So pi/2 lies within our range of -pi/2 to +pi/2. So sine inverse of 1 is going to be pi/2 when sine of pi/2 equals 1. Does that make sense? Adrian? Medina? Kind of? What part are you confused over? So when you're working with these inverse functions, you actually have to think about what the original function behaves like. Because remember again what I told you, your x and y values interchange, right? When you go from the original to the inverse function. So if they're asking you sine inverse of 1, basically they're asking you when, for what value of your angle is sine going to equal 1. So sine is equal to 1 only at this unit circle value, right? Because you're going to have 1, 0 as our ordered pair here at the starting point. So your sine function is 0 at the 0 angle. Sine function is 0 at the pi angle, right? Only at pi/2 and 3 pi/2, your sine function is going to be 1 or -1. Now, since they are specifically asking us, where is sine of y going to be 1 at, that is the only point, and that angle is your 90-degree angle, or in radians, it's pi/2, right? And as long as pi/2 is going to fall within the range of your sine inverse function, you can use that number. If it falls outside of this range, then you would say there's no answer to it, right? But since pi/2 is, of course, this upper limit of our range, we can use that, so that's why your answer is going to be pi/2. Does that make sense? Yeah? Okay. All right, so using that same idea, what do we have as part B here?
It doesn't exist.
Does not exist, sine inverse of -2.
Because it exceeds everything.
Actually, domain. Yeah, because for the sine inverse function, your domain goes from -1 to +1, right? And range, of course, is what we were looking at up here. Goes from, yeah, very good. So since x equals -2, what do I want to say? I guess since x equals -2 is not within our domain, I guess there is no possible solution. You can kind of put it in your own words, but again, you have to be very, very careful about what values are acceptable and what are not acceptable within these constraints. Okay. Now we're actually looking at how can we go about graphing these inverse functions. So they are saying by definition, the equations of your arcsine and sine of y equals x are going to be equivalent as long as we have our y value between -pi/2 and +pi/2. So their graphs are going to actually end up looking the same. So they are saying from this interval of -pi/2 to +pi/2, assign your values and then create a table for sine of y equals x. So we're again actually going with the original function and then using that to help us graph the arcsine function. So instead of actually kind of trying to figure out what the x values for the arcsine function is, you're actually using what the y values for the sine function is going to be, which will then lead us to getting the arcsine of x function. So as you can see, we're doing the same thing. We're taking our interval from -pi/2 to +pi/2, and then we're finding all the intermediate points in the middle. So we know at -pi/2 and +pi/2, we are at -1 and +1, and then you're just trying to find the intermediate values. So this is the part where you want to be careful about. If you're taking -pi/4, you're actually putting it in this function, right? Sine of y equals x, and x is actually this value that we have down here that we are calculating. And then of course, once you have your points, you can draw your graph here. So that was the graph we looked at here on this page. So this is what it would end up basically looking like. So we're going to try and replicate some of that. They are actually asking us to use a graphing utility, but we will be doing this by hand. So I guess we're not using a graphing utility. Okay, so they're asking us to graph sine of x, arcsine of x, and also the line y equals x in the same viewing window to basically verify that they are going to be inverses of each other. So let's see if we can do this. This guy would be number 2. Okay. So how would we go about doing just our sine of x function? Very good. Amplitude of 1, period of 2 pi. And then for our key points, what would we do? Where would you start at your x value? Yeah, you would start at 0. Yeah. And then you remember you are going to 2 pi. So at 0, what is sine of x? 0. At 2 pi?
Zero?
Yeah, because you come a full circle, right? So you actually end up at the same point. Now, what are those 3 values that we can use on the inside for the other 3 x values? So what's halfway between 0 and 2 pi?
Or no,
Pi, so this guy will go here. Halfway between 0 and pi, pi halves, and halfway between pi and 2 pi, 3 pi halves. Very good. At pi, what is our sign? 0. At pi halves, and at negative, 3 pi halves. Alrighty, there you go. So let's do our graph down here. And remember, on this same graph, we will be doing our arcsine of x also. So you are starting at 0, pi halves, pi, 3 pi halves, and 2 pi. And I'm actually going to replicate that on the negative side. So we're starting at 0, amplitude is 1. So pi halves is 1, pi is 0, 3 pi halves will be negative 1. And let's see if I'm at here, I should be at a minimum here, intercept, maximum, intercept. Okay, so in red we have sine of x. Now think about this. How are you going to graph the arcsine of x? Very nice. Yeah. So for y equals arcsine of x. Oops. Interchange your x and y values. So we had 0, pi halves, pi, 3 pi halves, and 2 pi, right? For the x values, that will now become the y values. And then what will be our corresponding pair to that? What's this guy? 1, 0. Okay, so how are we going to graph this on our y-axis now? Okay, pi halves is approximately what value? 1 point something? 1.5. So about, if this guy here was negative 2 and 2, you would be somewhere in the middle. Okay, so if this guy is positive, pi halves, negative pi halves, we would be going still at 0, 0, 1, and pi halves. This is going to be interesting because you need to have 1 on the x-axis also. 0 and pi, negative 1, negative pi halves. Okay. So technically, these would be curves going on the y-axis, right? Just as a rough sketch, they should be going this way for the arcsine function, right?
Yeah.
Okay. Now, for us to be able to do inverse functions, we are restricting the domain of our sine function, right? So in that sense, when you're looking at the sine function, you're actually only going to be looking at this and this, right? And basically the idea is we would have to ignore all of this part because they're not one-to-one if you include that. So you are basically restricting your sine function to stay between negative pi halves and pi halves like we saw earlier in this section. And then that means your arcsine function will be restricted between -1 and +1 on the x-axis, and negative pi halves and positive pi halves on the y-axis. Now, they're actually also asking us to graph the, let me see if I can do this because this is actually a little bit off scale here, but that's what your y equals x line should look like. And the reason we're doing that y equals x line is so that you can see that these guys end up looking like reflections of each other. So that's the one thing I want you guys to keep in mind. You're doing your original function, and that's okay if you draw, your period, but then you got to remember you are restricting your domain, which means we don't really need the remainder of this graph. You can scratch it out or cancel it out, but since we're restricting the domain, that's the only portion of your arcsine function that you're going to be seeing. Also because it automatically gets restricted by those values of your x and y coming from the original sine function. Now, what would you comment on the domain and range for both the sine and the arcsine function for our specific example? Okay, so the green graph is our restricted sine of x function, and then the blue would be our arcsine function, which will be restricted between -1 and +1. So for domain of the sine function, what can we say for this particular example? Yes, very good. So the domain would go from negative pi halves to positive pi halves. And what would be the range for the sine function? Very good. -1 to +1. And then what becomes of the arcsine function for the domain and range? Very good. Yeah, so same idea of interchanging our x and y values. All righty, very good. Okay, let's talk about the arc cosine function. So same thing's going to happen with the arc cosine because it will fail the horizontal line test if you keep the function as it is. So again, we are restricting it, but this time the way the cosine function works, since we actually start at a maximum point, you're actually going to restrict your domain from 0 to pi instead of going from negative pi halves to positive pi. And again, the idea is you should be covering the entire range of your cosine function. So again, we've got -1 here, we've got +1 here. So again, restricting our cosine function from 0 to pi halves. And again, you can use arc cosine or cosine inverse as the notation. when we are talking about the tangent function. Now, of course, a tangent function is not a continuous wave, but you do have that repeating pattern in a tangent function. So same thing, tangent will also be restricted from negative pi halves to pi halves. Now you will notice the tangent function interval is with parentheses, right? We're not including negative pi halves and pi halves, and what's the reason for that?
Goes with the asymptotes.
Very nice, yeah, because you actually have vertical asymptotes at these two values, so you cannot include them, but that's definitely the interval we're going with. And then of course you've got your arctangent or tangent inverse notation, and all of these will follow that same relationship like we looked at with our sine function. So if you have y equals arc cosine of x, that would be the same thing as cosine of y equals x, and same thing, y equals arctangent of x would be tangent of y equals x. Look at the domain for your arcsine function. We know it's going to stay between -1, +1. Actually, the same thing for the arc cosine function, because again, remember the range of the original cosine function is from -1 to +1. But look at this guy, arctangent. Because remember those arms for your tangent functions go to positive and negative infinity on the range, right? So that range now becomes the domain of the arctangent function. And then of course, with our restrictions, your range will be negative pi halves to pi halves, including the endpoints for sine, 0 to pi halves, again, including the endpoints for arcsine, but not including the endpoints on the arctangent. So you're only going from negative to positive pi halves. And then they have all of our graphs here for the three inverse functions. So you can see on the arctangent, your vertical asymptotes are now becoming horizontal asymptotes, right? So these arms will go closer and closer to this horizontal line of pi halves, but not touch it, not cross it. And then of course we've got x and y intersect at that origin of 0, 0. And then you can look at your other graphs for arcsine and arccosine. Are we okay so far, especially that relationship between the original function and the inverse function? Some of this will just come down to remembering what that domain and range is and how we are restricting it. So let's look at how we can evaluate these cosine, arctan functions here. So they're asking us to find the exact value of arccosine of square root of 2 over 2. So square root of 2 over 2, you should remember, comes from that 45-degree triangle, right? So that means at cosine of what angle do we get square root of 2 over 2, which is right at 45 degrees. So that would be your pi over 4. So arcsine of square root of 2 over 2 has to be pi over 4. Arctangent of 0, which means at what value is tangent equal to 0? Because tangent is defined as sine over cosine, right? So basically anywhere where your sine value would be 0, your tangent value would be 0. Because what happens if 0 is for cosine? You would have undefined, right? So where are sine values 0 at? No.
Is it 0?
0.
And 180?
Yeah, exactly, at 0 and at pi, but we cannot use pi because pi would be outside this range, right? Because pi is more than pi halves. So you're only looking at 0 in this case. Same thing on part C. They're asking you what is the value of arctangent of -1, which means at what angle is tangent equal to -1. And tangent is equal to -1 again for that 45-degree angle. So that's going to be at pi over 4. All right, so I'll give you guys about a minute. Think about it and tell me what you think the answer for cosine inverse of -1 should be. Problem number 3. Cosine inverse of -1, which means they are asking you at what angle is the cosine function equal to -1. So if it helps again, draw a unit circle to help you out. Medina, do you know? When is cosine of x equal -1? Three pi over 2, which would be this angle here.
Yeah.
Right? So for this angle here, what's the ordered pair? No, just think in terms of x and y coordinate. What's the ordered pair? 0, -1. And remember, cosine is always the first coordinate, right? So that means cosine is actually 0. You're looking for where cosine is -1. Sine is the y. Yeah, x is the cosine. So then what other place could you find your x to be -1 at? At pi. Yeah, very good. So at this ordered pair, you have -1, 0. So now the idea is pi within our domain for the, not domain, sorry, range of the cosine, arc cosine function. Yeah, because what's the range for the arc cosine again?
0 to, yeah, exactly.
Okay, we can go back.
Yeah, 0 to pi.
Yeah, exactly, because arc cosine goes from 0 to pi, so pi is that upper limit. So you can actually use pi as your angle here. So yeah, this guy would be equal to pi, which is within 0 to pi as the range. Does that make sense? Any questions on that? Because this one is, these questions, you have to be very, very careful about remembering what the accepted domain and range values are, because the moment you step outside of that, obviously, we don't have the right answer anymore then. Did anyone have questions on this guy? Okay. Now we're getting into approximate value. So this is the part where you can actually use your calculators. So they're asking us to calculate arctangent of -8.45. So this is actually where you use those inverse keys on your calculator, the tangent inverse, put your little negative sign in there, 8.45, and you should be able to get your approximate value. Same thing for your sine inverse of 0.2447 and arc cosine of 2. I actually want to have you guys try the arc cosine of 2. What do you get when you put that in?
It's just going to say because it's beyond the.
Because it's beyond the domain, right? Because your domain for the arc cosine function only goes from -1 to +1. So arc cosine of 2 should not give you an answer. There should be an error message. Okay. Ezra, I'm going to pick on you because last time you were the only one who made this mistake. Please make sure your calculator is in the right mode. Because if you're not in the right mode, obviously the answers come out looking all kinds of funky.
It's radian. It's degrees.
No, because there's no degree symbol on any of them, right?
So it's radian.
So it's all radians. Yeah, so you are given. Okay, for part A, arctangent of 4.84. I did not get a negative answer. What did I do? Okay. So arctangent of 4.84. I'm getting a positive value. Yeah, 1.36. Yeah, and which one were you doing?
I was doing the example.
Oh, okay. Yeah, that one is negative. So now I got to remind Ezra to do the right problem also. Yeah. Oh, it's okay, Ezra. You got it.
It's like a secret. You got this.
You got this. There you go. Okay, so what should we notice on part B? And why are we getting that error?
Because
It's outside of the domain, yeah, because negative 1.1, you can only go as far as negative 1. So since this is outside of the domain, there's no answer. So outside of the domain, which is from negative 1 to positive 1. And then part C is asking you for arc cosine of negative 0.349. And that's definitely within range or within the domain. Okay, I did something wrong. This is arc cosine of negative 0.349. Alrighty, very nice. 1.927300. And I'll give you guys a rounding limit when we do this on the exam. Right now, there's really no instructions on how far you need to round it. So I'm not really worried about the calculator portion. I'm sure you guys can do that. Just make sure your mode is in the right format. But it's those exact values that I would definitely insist you guys to practice on so you get a little more comfortable coming up with those exact values. Because again, like I said, calculators would not be that hard to work through. Okay, and so that little example, that little paragraph is just talking about making sure you're working with the right mode in your calculator. All righty. Any questions so far? No? Okay. So we're getting into the composition part of these inverse trigonometric functions. And you know, again, this comes down from your college algebra class. If you remember, and this was like chapter 2, I think, we had talked about if you take two inverse functions and you do their compositions, the answer always comes out to be x, and we're basically saying f and g are inverses of one another. So that's the same exact rule we are using here. So if you have two inverse functions, f and f inverse itself, and you take their composition, you should always come out with that variable x as your answer, and it really doesn't matter in what order you do the composition. You're always going to get that. So again, you can review your section P10 here, or of course you can review your notes from college algebra if you like. So this is kind of what I was showing you earlier to remember the relationship between arc sine and the sine function. So this is kind of where we're going at. Your x values are going to be restricted between -1 and +1. Your y values are restricted between -pi-halves and +pi-halves for the arcsine function. So if I do a composition of sine composed with arcsine of x, you will get x as the answer. But if I am doing arcsine with sine of y, then of course that same variable y is going to be your answer. Same thing with your arc cosine. This your x values are bounded by -1, +1. Y is bounded by 0 and pi. So again, cosine composed with arcsine will give you x. Arc cosine composed with cosine will give you y. And then of course for the arctangent function, domain is any real number, right? Domain goes from negative to positive infinity, but range only goes from -pi-halves to +pi-halves, not including the endpoints, but you would still notice that same relationship here. So you can actually use this to also help you kind of come up with some of these exact values for these functions. So they are saying, keep in mind that they do not apply to any arbitrary value of x and y. If they do not stay within the domain and range of these functions, you cannot use this rule of composing the two functions will give you. So what's happening here with 3pi-halves?
It's over the domain.
Yeah, it's not going to be part of the domain and the range for the restricted functions, right? So when you're actually doing arcsine of sine of 3 pi halves, you're not going to get 3 pi halves as the answer. You are actually going to end up going to the negative side. So we're actually, instead of going counterclockwise, you are still coming to the same point, but you're actually going to go in that clockwise direction to come to the exact same point. So again, think about your unit circle in this case. So if this is my unit circle, this one here is 3 pi halves when I am going counterclockwise, but if I go clockwise going this way, then he is negative pi halves, right? So you're still ending up at the same point, but because of that restriction of our domain, instead of writing it as positive 3 pi halves, you're going to write it as negative pi halves, okay? So you're actually going to see something similar in this example 5 over here. Arctangent of, arctangent of negative 5. So in this case, since we know the arctangent function has a domain from negative to positive infinity, negative 5 is okay to use. So you can actually end up getting negative 5 as the answer on that part A. Part B, you have arcsine composed with sine of 5 pi over 3. Now this is where we're going to run into an issue, right? Because you cannot have 5 pi over 3. So here you're actually going with, do you remember what this angle is called when we subtract 2 pi from it? No, those are 90 degrees and 180. Coterminal, right? So it's the coterminal angle. So they're using negative pi over 3 because again, he's going to be within the range and 5 pi over 3 will not. And then your last one is cosine inverse, cosine composed with cosine inverse of pi. And of course, this guy would be undefined because cosine inverse has a range of only -1 to +1, right? And pi is 3.14, so you know he's well outside of that domain, so you won't be able to find the answer for that. All right, so using that same idea, you guys have example 5 with 3 parts to it. So again, I'll give you guys a couple minutes. Let me see what answers you come up with, and then we'll discuss the answers. You have all your answers already? Yeah, okay. So the first thing you are looking at is for the inside function, like tangent inverse of -14, is it going to be in the domain of the tangent inverse function? And then the answer you get, is that going to be in the range of the tangent function? So Ezra, what did you say for number part A?
I said that it was going to be -14 because the domain is negative infinity to positive infinity.
Yeah, very good. Tangent inverse has a domain of negative to positive infinity, which actually then becomes the range of the tangent function, right? So yeah, these guys will actually follow the rule, and you will be able to get -14. Okay. Medina, do you got part B? Very good, because again, for the sine function, with the restricted domain, you can only go from negative pi halves to positive pi halves. So you have to actually first rewrite that angle. So you take 7 pi over 4 and subtract 2 pi from it, and you got, you said what, negative? negative pi over 4, very good. And then you can do negative pi over 4. And what is sine of negative pi over 4? Well, sorry, the sine inverse of sine of negative pi over 4.
Oh, just negative pi over 4.
Yeah, because now negative pi over 4 is going to be in the domain of the sine function, so you can use your inverse rule properties and get negative pi over 4 as your answer. Okay, so that leaves Adrian Flores. What do you got for part C?
So for our cosine,
The domain is what?
is 0 to pi. And then cosine.
No, arc cosine. What's the domain again?
It's 0 to pi.
I thought it was negative 1 to 1.
Oh, negative 1 to 1.
Yeah.
No.
Yeah, because cosine has a range of negative 1 to 1, so that should become the domain for the arc cosine. So your 0.54 is well within that range, right? So yeah, you can actually solve this. And what did you get as your answer? You didn't finish it?
No.
Okay, sorry. Yeah, it is going to be 0.54 because since it's within the range, you're safe. All righty. Okay, how about we stop here so that gives you guys 15 minutes for the quiz. So we'll pick it up from example 6 next time.